Today we are going to be solving problem 3.3 from Math Methods by Riley by writing pi over 12 as pi over 3 minus pi over 4 and considering the expression e to the I pi over 12, evaluate the cotangent of pi over 12. Let's start by considering that exponent first, and we'll use Euler's formula to write this as cosine of pi over 12 plus I times sine of pi over 12. Then we'll write this as the difference between pi over 3 and pi over 4. Now we want to simplify this further, so we'll use the result from problem 3.2, which allowed us to find equations for cosine of theta plus phi and sine of theta plus phi. You could see my previous video on that, solving that problem. But for now, I'll just write the equations. Now we can label pi over 3 as theta and then negative pi over 4 as phi. And we want to keep the negative in phi because these equations, cosine of theta plus phi and sine of theta plus phi, use a plus sign explicitly. And this will be theta and this will be phi. So now using the first formula, we'll have cosine of theta, which is pi over 3, times cosine of phi, which is negative pi over 4, minus sine of pi over 3, times sine of negative pi over 4, plus I times sine of negative pi over 4 times cosine of pi over 3 plus sine of pi over 3 times cosine of negative pi over 4. Now from the unit circle, we know that cosine of pi over 3 is equal to 1/2. Sine of pi over 3 is equal to the square root of 3 over 2. And then cosine of pi over 4 and sine of pi over 4 are both equal to radical 2 divided by 2. So we'll have to use each of these results, as well as the oddness and evenness of sine and cosine. So we know that cosine is an even function, which means the cosine of a negative argument will simply yield cosine of theta, and that negative sign goes away. Now if we want to examine sine of negative theta, sine is an odd function, so that negative comes outside. Using all of these facts, we can simplify this equation here. So we'll have e to the I pi over 12 is equal to 1/2. Cosine's an even function, so the negative goes away and we simply evaluate cosine of pi over 4, which is radical 2 over 2. Then we have minus sine of pi over 3 is radical 3 over 2 times negative, because sine is an odd function, radical 2 over 2, plus I times sine of negative pi over 4 is negative radical 2 over 2 times cosine of pi over 3, 1/2, plus radical 3 over 2 times radical 2 over 2. Now let's simplify this by multiplying all of them together. Now remember that we're trying to solve for cotangent of pi over 12. Remember that cotangent of theta is cosine theta divided by sine of theta. So cotangent of pi over 12 is going to be the cosine of pi over 12 divided by the sine of pi over 12. But remember from Euler's formula, this quantity here is just the cosine of theta, really the cosine of 12, pi over 12 in this case. And this quantity in parentheses is the sine of pi over 12. So we already know these two values. Plugging in, we get the square root of 2 over 4 plus the square root of 6 over 4 divided by the square root of 6 over 4 minus the square root of 2 over 4. I just switched the order there. Let's factor a 1/4 from the numerator and the denominator. These cancel. And remember that the square root of 6 is the square root of 2 times the square root of 3. I'll just keep that off to the side. So the square root of 2 plus the square root of 2 times the square root of 3 divided by the square root of 2 times the square root of 3 minus the square root of 2. Notice that we can factor the square root of 2 out, and we get 1 plus the square root of 3. And we can do the same in the denominator and get the square root of 3 minus 1. Now the radicals 2 cancel, and we have an exact value for the cotangent of pi over 12, which is simply 1 plus the square root of 3 divided by the square root of 3 minus 1. This value exactly in decimal form is 3.73. And that's it.